Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss about definition and terminology regarding to the organization of a computer. The first term is define implied or implicit addressing mode. The addressing mode specifies where the operand is available. A variety of addressing modes are available. In the implicit addressing mode, the definition of instruction itself specifies the operand. So, implicitly, the operand can be described with the help of implicit addressing mode. The operands are directly specified instead of their addresses. The instruction format can consist of majorly two parts, the opcode and the address. So instead of specifying the address of the operand, the actual operand value can be specified in the implied or implicit addressing mode. The example, add 7. CMPB, INCAC. So the values can be directly available in the register, can be used to implement the specified micro operation. So here the operands are readily available so that the micro operations can be performed and the speed of execution of this implicit addressing mode instructions are very high. Define stack addressing mode. So here the CPU organization can be majorly categorized into register based organization, single accumulator organization, stack based organization. In the stack based organization, the operands can be stored in the system stack, and with the help of stack pointer SP, the insertion and deletion operations can be carried out on the stack. When a data item is inserted in the stack is generally referred as push operation, and when a data item is retrieved from the stack is generally referred as pop operation. In the stack addressing mode, the operands can be stored in the stack and they are retrieved in order to perform the specified micro operation. These stack addressing mode instructions are generally zero address instruction. Here, what actual micro operation can be performed is specified in the assembly language and the operands can be retrieved from the stack using the stack pointer. So, in this mode, operands are available at the top of the stack. In order to implement the add operation, the two operands can be popped from the stack and they can be perform the add micro operation and the result can be pushed to the top of the stack. So here the operands are stored in the stack and can be retrieved to perform the micro operations. So the assembly language instruction, simply we have to perform what micro operation can be performed on the operand like add, sub, mul. So these instructions are generally referred as zero address instructions. What is immediate addressing mode? In this addressing mode, the operand is part of the instruction instead of the content of the register or memory location. So here the instruction format can contain the two parts. One is the opcode, second one is operand. So here the operand can specify address of the operand And here, instead of the content of the register or memory location, the instruction address part itself specifies the operand. Since the data is encoded directly into the instruction, immediate operand normally represent constant data. So, how to apply this immediate addressing mode is add R1, 50. So, here the address can be specified here, and the 50 value can be added with the value stored in the register R1, and the result sum can also be stored in the register R1. So here the address of the operand can be fabricated with the instruction itself. So immediately it can fetch the operand value and can apply the micro operation. Define direct addressing mode. In this direct addressing mode, the address field of the instruction contains the effective address of the operand. Only one reference to memory is required to fetch the operand. So in the instruction format, two parts are there, the opcode and the address. Generally in a 16-bit register, here 0 to 15 bits are there. The 15th bit is used to specify whether it is a direct addressing mode or indirect addressing mode. This mode can be represented with the I value. If I value is 0, then it is a direct addressing mode. If I value is equal to 1, then it is a indirect addressing mode. In case of direct addressing mode, the effective address of the operand can be specified at this address. So it is also called as absolute addressing mode, and we can use the square bracket symbol to represent the address of the operand. So here opcode in the instruction format, and here this is the address. By using this address in the memory location can be identified to fetch the operand value. So the example is load R1, 100. Add AL within square bracket, the address can be specified here. So the direct addressing mode, the direct addressing can be specified with the help of square bracket. What is indirect addressing mode? In this addressing mode, the address field of the instruction specifies the address of the memory location that consists of effective address of the operand. So here, if you take this is the opcode and A address, the instruction format. So with the help of this address, the memory location can be traversed. There we can find the effective address of the operand. Hence, one more memory location can be needed to traverse to fetch the operand. So, two memory cycles can be needed to locate the operand. How the system can recognize it is an indirect addressing mode means, in the instruction format, the I value that is specified at the 15th bit. If I value is equal to 1, then it is an indirect addressing mode. So, two memory cycles are required to fetch the required operand value. So, the address that is specified in the instruction format can be used to get the effective address of the operand. So, this requires one memory cycle. And by using this effective address, the actual operand value can be retrieved with the help of another memory cycle. So, two references to memory are required to fetch the operand. So, the symbols that can be used to denote the indirect addressing mode is @ or parenthesis. Now, we can discuss with example how to specify this indirect addressing mode. So here add R1 comma @100. So this is the @ symbol is used to specify the indirect address. So at the location of 100, the effective address of the operand can be stored. Define register direct addressing mode. In the register referenced CPU architecture, this register direct addressing mode can be used. So in this addressing mode, the operand to be accessed is present in the CPU registers. With the help of CPU registers, the operand can be stored and can be retrieved. Actually, all computers are usually provided with some addressable registers. For example, k bits of the operand field can denote any 2 power k registers operand holding the data word. So, CPU registers are majorly involved to specify the operands. So, here opcode can be specify the micro operation add, and the two operands operand 1 and operand 2 can be specified with the help of CPU registers. Operand 1 is available in the R4 register, operand 2 is available in the R3 register. So R4 value, the register 4 which stores the value, can specify the address of the memory location where the operand is available. So the first operand is retrieved with the help of register R4. So here the value can be specified in the processor register. That value can be retrieved and can be used in the add micro operation. And here the operand is stored in the register R3, and that value, the second operand, can be retrieved and stored in the micro operation add. How to apply this register direct addressing is add R1 comma R2. So with the help of CPU register, the two operands can be stored in the register R1 and R2 respectively and can be used in the micro operation addition. Next, INC R2, the register value R2, that is the value stored in the register R2, can be incremented by 1 with the help of the micro operation INC. What is graphics coprocessor? So the graphic coprocessor is a accelerator or it is a separate subsystem and can be incorporated into the graphics. The coprocessor of the CPU handling graphics intensive tasks. If the application which involves more graphic intensive tasks like 2D, 3D effects, geometry, those effects has to be usually performed with the help of graphics coprocessor, so that the resolution can be very high with the help of graphic coprocessor. The graphic intensive applications generally can be implemented with the help of graphic coprocessor. It performs various 2-dimensional, 3-dimensional geometry, rendering functions, offloadings. With the help of the CPU, this graphic coprocessor can perform all these graphics intensive tasks. Define nano programming. The micro instructions are not directly used by the decoder to generate control signals. So this is achieved with the use of second control memory called nano control memory, and it is denoted with NCM. So here the second control memory can generate this nano control memory can be used for the nano programming. So, in the most programmed processors, an instruction fetch from memory is intercepted by a microprogram stored in a single control memory. Generally, the control memory can be used to store the microprogram, and the instruction can be fetched from this control memory. In some microprogrammed processors, the micro instructions are not directly used by the decoder to generate the control signals. They are used the second control memory. There are two levels of control memories. A higher level control memory known as micro control memory and lower control memory known as nano control memory. In a processor, if two levels of control memories are established, the higher level can be generally referred as microcontrol memory, and the lower level control memory is generally referred as nano control memory. The control memory stores micro instructions, whereas nano control memory stores nano instructions. So this is the structure of nano programming. So from the sequencer, microprogram counter can be used, and microcontrol memory and micro instruction register can be used to fetch the micro instructions. Nano program counter, nano control memory, nano instruction register can be used to fetch the nano programming instructions. So two separate control memories can be established. The lower level control memory is the nano program control memory, and with the help of nano program counter, nano control memory, nano instruction register, the nano program instructions can be executed. What is the advantage of this nano programming? Reduces total size of required control memory, greater flexibility to store the programs either in microcontrol memory or in nano control memory. But disadvantage is loss of speed due to extra memory access is required. To fetch the instruction, looking and searching for the two level memory hierarchies are required. So that is the disadvantage of nano programming. What are coprocessor control instructions? The coprocessor extends the instruction set of the base architecture. So the instruction set architecture specifies the instruction set, addressing modes, and memory control functions. With the help of this coprocessor, the instruction set can be extended to support high precision integer and floating point calculations. For the scientific applications and engineering applications where required the high precision integer and floating point calculations are required, these coprocessors can be used. This extended instruction set includes arithmetic, comparison, and data transfer instructions. So they can specify the processing of high precision and floating point calculations, which involves the arithmetic processing, decision capacity with the help of comparison or logical and bit manipulation instructions, and also support data transfer instructions like move, load, store instructions. The processor has control instructions for initialization, exception handling, and task switching. So they are majorly used for scientific and engineering applications. The exception handling and also task switching capacity can be performed with the help of coprocessor extended instruction set architecture. State Univac. The full form of Univac is Universal Automatic Computer, and it is developed in 1950. It is an example of first generation computer. During the decade 1940s to 50s, these first generation computers can be available. The major electronic component that is used in this Univac is the vacuum tubes. So here the use of vacuum tubes, the size of the computer is very big. This is the layout of the Univac computer. And here vacuum tubes can be used as major component. So the heat generated from this computer is very high. So AC can be required, and here the power consumption of these computers can also be very high. So Univac is best example for the first generation computer, and the full form is Universal Automatic Computer. The sample layout of Univac is this. Define programming language. So here a programming language is a computer language that is used by the programmers to communicate with the computer. So with the help of these programming languages, the programmers can develop the computer code. So it is a set of instructions written in any specific language. Various programming languages are available. So by using this, the set of instructions can be developed to perform a specific task. A programming language is mainly used to develop desktop applications, website applications, and also mobile applications. A variety of programming languages are available. Majorly the high-level language and the low-level languages. The low-level languages are further categorized into assembly language and the machine language. The computer is generally understood the binary language which is composed of zeros and ones. The machine code is composed with of zeros and ones, so the machine code can be directly understood by the computer. The assembly language can use some mnemonics in order to facilitate the flexibility to the programmer. So here the mnemonics that can be used in the assembly language should not be understood by the computer. So they require an assembler. Assembler is a program which converts the assembly language instruction into the machine language. So here the mnemonics can be used to specify the micro operations like arithmetic instructions, add, sub, mul, and logical instruction and or exclusive or. Like that, variety of mnemonics can be used in the assembly language to perform the to construct the assembly language program. So assembler can be required to convert the assembly language program to the machine code. In case of high-level language, the natural language instructions can be used to construct the program. So it increases the users the flexibility, the ease of code with the help of high-level language. So here in the natural language processor, the code can be developed with the various syntax that are available with the control structures and looping structure statements that are available for that particular language. So if then else, while loop, like that, these constructs can be used to develop the code. But this code cannot be understood by the computer, so they need a translator, that is either the compiler or the interpreter. The compiler is a software that takes high-level code as input and converts into the machine code. Interpreter can also be used for the same function, but the difference between compiler and interpreter is compiler can convert the whole program at a time into the machine code, but the interpreter can convert line by line. Define bus. The computer bus is the major communication path between various devices that are available with the computer. So a bus is a communication pathway connecting Two or more devices usually broadcast the signals. The layout of the bus is like this. So here this can be the system bus. The system bus can consist of three types of buses. One is address bus, second one data bus, third one control bus. The central processor unit and the memory system can be connected with the address bus, data bus and control bus. And the I/O devices can be connected with the processor and memory system with these three buses. The address bus can be used the address of the memory location where we have to perform the operations on the memory. The data bus holds the data which can be read or written from the memory. So the data bus is a bidirectional. The data can be read or written from the memory location. The control bus carries the control signals like the read or write operation control signals. So the control bus is also the bidirectional. Address bus is used to locate the memory location, so it is a unidirectional. The address bus, data bus and control bus together can be referred as system bus. What are the types of system buses? So the data bus, address bus, control bus are the three types of the system buses. Data bus carries the data. The width is the key determinant of the performance. Generally, the data bus can be of 8, 16, 32, 64-bit width. Address bus is the second variety of bus of the system bus. The address bus identify the source or destination of data. Example, CPU needs to read an instruction or data from a location in memory. Bus with determines maximum memory capacity of the system. For example, if it all 16-bit address bus, the address space of the memory is 2 power 16 64K. So the width of the address bus determines the address space of the computer. Next, third bus is the control bus. The control and timing information can be carried with the help of control bus. The general control signals that can be traveled with the help of control bus are memory read, memory write, I/O read, I/O write to perform the I/O operations with the help of I/O devices and transfer acknowledgement. In case of direct memory access DMA, bus request, bus grant, interrupt request, interrupt acknowledgement, clock reset can be used as control signals that can be traveled through the control bus. All these three buses can be considered as the system bus. What is bus transfer in register transfer language? The transfer of information from a bus into one of many destination registers can be accomplished by connecting bus lines to the input of all registers and activating load control of selected destination. The symbolic statement of bus transfer may mention the bus may be implied in the statement. So, the symbols generally 4 notations can be used in the register transfer language. The capital letters can be used to specify the registers, and the part of the register can be specified with the parentheses. The lower part and higher bits of the register can be specified with the parentheses. For example, R2 is a 16-bit register. R2L means which is denoted with the 0 to 7 bits. If it all R2H means it is used to represent 8 to 15 bits. So the part of the register can be generally denoted with the parentheses, and the data transfer can be represented with the arrow marks. The direction of transfer can be represented with the arrow marks. And if it all multiple RTL sequence of instructions are there, those can be separated with comma. So here, if you do this example, R1, the value stored in the register R1 can be transmitted to R2. And here, in case of bus is involved for the data transfer, the R1 data, the value stored in the register R1 is transmitted to the system bus. The bus carried value can be transmitted to the register R2. Like this, the bus transfer can be denoted with the help of register transfer language. What is memory transfer? The transfer of information from a memory unit to user end is called the read operation. Generally, two operations are performed on the memory, read operation or write operation. So, the transfer of information from a memory unit to the user end is called the read operation. Here, the information is fetched or retrieved from the memory. The transfer of new information to be stored in the memory is referred as write operation. So here the data can be written into the memory. The memory word is designated with the letter capital M. User must specify the address of memory word while writing the memory transfer operation. The address register is designated with AR and the data register is designated with DR. So with the help of two registers, the read and write operation can be performed on the memory. So the registers that involved are AR address register, which holds the address of the memory location, DR data register, which carries the data to be written or read from the memory. So this is the memory unit. So here read and write signals can be there, and AR is the register that can use to locate the memory location or address. The data can be out, which can be generally referred as read operation. Data can be in is generally referred as write operation. So the read operation can be specified as in the memory word that is specified at the address with the help of address register, that value can be transferred to the data register. So the read statement causes a transfer of information to the data register DR from the memory word M selected by the address register AR. Now, what is write operation? The write operation can be stated as the register R1, which contains the value, can be transferred to the memory address specified with the AR. The new information, the register R1 content can be transferred to the memory address that is specified with the AR. The write statement causes a transfer of information from register R1 into the memory word M selected by the address register AR. Now, what are the various lines that are needed for memory transfer? So, for the memory unit, what is the lines that can be required? So, here, address line, read and write signals can be the input of the memory. So, memory unit, and there is n data input lines and n data output lines. If it are k address lines are connected to the memory unit, then the address space of this memory unit can be 2 power k words. For example, 4 address lines are connected with the memory unit. The address space 2 power 4 16 is the address space. And in the memory, generally 2 operations are performed to facilitate that the read and write lines can be given as input of the memory unit. Not only that, the collection of bits can be generally referred in the memory is with the help of words. So how many bits can be collected per a word is decided by the n data input lines. If at all 8 data input lines are there, then 8-bit word can be used. 8 bits can be collected as a to refer the memory word. So this memory can be 16 by 8 memory. And if n data input lines are there, then there should be n data output lines. So these are the various lines required for memory transfer. So n data input lines provide the information to be stored in memory, and the n data output lines supply the information coming out of the memory. The k address lines provide a binary number of k bits which can specify the words chosen among 2 power k is the address space. The two control inputs specify the direction of transfer desired, that is the write operation or the read operation. Define miscellaneous instructions. Example of these instructions is interrupt or supervisory call or halt instructions are generally referred as miscellaneous instructions. Define state gates. A 3-state gate is a digital circuit that executes 3 states. So, generally the 0 state, 1 state, another 3rd state, high impedance state is available in the 3-state gate bus. So, 2 of the 3 states are normal logic states, state 0 and state 1, while the 3rd state is the high impedance state. The most commonly used 3-state gate is in the bus system is buffer gate. So what is the symbol used to denote this state gate? The graphic symbol to denote the state gate is this. So normal input A, output can be Y. Normal input B and output Y. In case of the control input is 1, Y is equal to A. So if at all the control input is 0, then the state gate can be turned into the high impedance state. So this is the 3-state gate bus. Define micro operation. In the control memory of the computer, microprograms can be stored. The instructions can be fetched during the instruction cycle from this control memory. The microprogram is collection of micro instructions. The micro instruction can be is of 2 parts, the opcode and the address. The opcode can specify the micro operation, what actual operation can be performed on the specified address or the operands. So micro operation, micro ops in short, can be defined as an elementary operation performed with the data stored in the registers. So during program execution in the instruction cycle, the first phase can be the fetching of instruction. So here later on decode it and collect the operands, execute it and identify if any interrupt is there or not. These are the steps generally involved during the program execution or instruction cycle. So after fetching the instruction format, the opcode can specify the micro operations. Variety of micro operations are available: arithmetic micro operation, logical micro operation, shift micro operation. Arithmetic micro operations generally adds the processing capability for the computer. Logical and bit manipulation instructions generally used to perform the decision making capability to the computer, and shift operations are used for serial transmission of data. So here the micro operations can be used for data manipulation or data storage and retrieval, and program control also these micro operations can be used. So these are the terms and definitions that can be related to the organization of computer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.